Now we'll look at the analysis part of our spreadsheet. Once again, let's just quickly review it. I'll delete all these out and then we'll refill them. We're analyzing the full assembly of our building except for the floor, taking the area and then doing a calculation to come up with total energy, summing that, then using degree days to come up with another total for the year and summing that. So let's go ahead and pull out these numbers. And you'll notice our chart disappeared over here. Let's hope we can get it back or whether it'll reestablish itself. So our wall area, our first wall area is a number. So if I go to this window and type equals, I can go and grab that number and hit return. I'm going to do the same thing, equal for our window area, return. Our roof area, equal, and return. And then our infiltration is our cubic volume. And let's see if I calculated that. I think I just put it in. So we know it's 20 foot by 20 foot by 10 foot. So it's 20 by 20 is 400 times 10 is 4,000 cubic feet. That's just really an approximation because we're always losing some of the floor area to the wall construction. So I'm just going to type that number in. Well, actually I can transfer it because, and actually we want to because I want to change my building volume here if we change any of the parameters, and I wanted to have it automatically update on the chart. So excuse me, we're going to grab that 4,000 and place it there. Okay, now we'll look at doing our calculations, which is really the meat on the bones of this project. So I'm going to go ahead and do equal again. I'm going to take the U value of our wall system over here. I'm going to multiply it by, and I'm looking up at this heat loss per hour, I'm going to multiply it by the area and then multiply it by our design temperature, our delta T, the worst day, and hit return. And you'll notice that number is the same, and luckily our chart has come back to life. And we'll look at how to make these in another clip. We have our window, so we'll go ahead and grab, we'll put a formula here. We're going to take equals, and we're going to grab our U value first for our window, and this is the analysis 1, window 1, so we'll grab that U value. And we'll take the area of that window, and then the delta T, and that gives us our loss, or our amount of, and I must have done something wrong there. It really, oh, maybe not. Let's see what I did. I got C30, C30. I think we're fine. Okay, so we'll do our roof now. Equals, we need our U value for our roof, times, which is asterisk, times the area, not showing, there it is, and then times the delta T. And then finally, the unique one there is the air infiltration, and that's based on air changes per hour, the volume of the room, the delta T, times this conversion factor. And we'll go ahead and get that started. So we're going to go down here and we're going to type equal in that box so it starts to understand it as a formula. We'll grab the building volume. We're going to multiply, oops, I'm sorry, we're supposed to grab the air change per hour first. Let's go back. I'm going to grab air change per hour times the building volume times the temperature, and then times 0.018, and I'm making reference to this formula up here, and that number matches that number, so we're all set there. Okay, so now for degree days, if you haven't done this already and gone through this, I went out to degree days, so I'm going to go ahead and click that hyperlink. That's going to open up another box, and I'll just show you how to do this. Alfred, New York, if that's where you want to do. Heating data type, last 12 months, base temperature 65, station search, Alfred. It's got a bunch of them here. You can pick any one you want. Let's do Wellsville. Generate degree days. It's downloading them. This will take a few seconds, and it's going to give us an Excel spreadsheet. Download it. I'm going to save it to the desktop, and I'm going to go ahead and open that. Excel will open for me. Somewhere. Here it is. Let me just bring it to the surface. It won't allow me to open two spreadsheets at the same time, but I'll bring over the one that was the last one I imported. So here we have the Wellsville data, the heating degree days, the months. These ones that are an asterisk are because there's missing data. They're estimated, but it's really not very little discrepancy from the estimate. Anyway, you can take this whole spreadsheet and copy it, and then go back to your spreadsheet, and then paste that in like I've done. And the only thing else you would do then is just sum up all of the values here. So I've done an equals sum of all of these heating degree days to come up with total heating degree days. And I've just imported, or I've just copied that number into here. So that is the G37 cell. So if I put a new chart in here or did anything else, that would automatically update all the way through. So with that idea of knowing our degree days for the whole year, we can then do a calculation of energy consumption for the whole year. So in order to do that, we'll go back to this cell, we'll do equals, and we'll use that degree day calculation. So we'll take the U value for the wall times its area times 24, because a degree day is a day, and we're usually looking at heat flow in hours, BTU per hour. So we have to multiply it by 24, and then times degree day, our degree days, and hit return. And we'll do the same thing for the windows, and actually all the way down. And I won't go, well, I'll do one more. So we'll go ahead and do another, we'll do the window 1 assembly. So we're going to do degree days. So we're going to go and grab, we're going to go equals, we're going to grab the new U value, oops, excuse me, the old U value, and times the area of the windows, times 24, times our degree day, and so on. So actually I'll do this out so we can go ahead and total it. So we'll go ahead and do our roof right away. We're going to grab the U value for our roof assembly times its area times 24 times degree days. And then the last thing is our air change per hour, and we're just going to substitute, we're just going to have to do the same thing as we did here, where we're going to put for T, we're going to substitute 24 in degree days. So we're going to start with air change per, oops, excuse me, we're going to go equals air change per hour times the volume of our room times 24 times our degree days times 0.018, our conversion or to BTUs per hour. And so all of those are in alignment. And we'll go into describing these formulas, or you have already in lecture. So let's look at now making totals. Very easy. Equal sum. I'm sorry, I lost track of what I was doing here. Equal sum, start a quote, and or parentheses, and we're going to do the same thing here. Equal sum And there we have our two values, and we're back to our pie chart. So you can go ahead now and look at analysis 2. Really the only difference is you're going to be using a new U value for your window, and that will give you less energy consumption because it's a higher performing window. And that's over here in the U values we selected. And the way we did that was, or the way I did it was I looked at the Home Depot U value, that was 0.3, and then I looked at what was a very good performing triple glazed, and that was 0.15. And I use those for values in our calculations. So we'll pick up with that and looking at just about how to make our charts here next.